In 2022, Google engineers make some experiment, and it was so simple that it sounds like a joke. So they give a math problem to state-of-the-art model, and it's failed to solve. Then they add just one line into the prompts, and then model was able to give the right answer. Right? Accuracy jumped from 17.7% to 56.9%. Sounds like a free upgrade, right? Every engineer should use that always. We shouldn't. Just hold that thought for 15 minutes and you will find out when thinking actually pay off and when we should actually use it, right? So in last chapter, we left off, we have an LLM which is really good. It has a lot of knowledge. It was predicting the next tokens. It was very brilliant. But the question was, can we make it think harder, right? That's where we left off. So the thing is, we can. And what is the response? It is very simple. Just ask it, tell it to think step by step. That's all. If you just add one line into the prompt that do it step by step, it will be amazing, right? So we'll see like how this work. So that they give this problem to model. Like I'm using the same problem which was referenced there because it was very simple. So say like Roger has 5 tennis ball, he buys 2 more can. Can means like just in box which contain like 3 balls each. How many tennis balls does he have now? So the response was 27, and it was like quite weird. So you can try this. If you give this to chat gpt, right now it will not give you the response. It will do something different. And what it will do, so next is with chain of thought. When I say chain of thoughts, which means like just breaking the problem into smaller steps. So now just if you they added one line which they like let's think step by step. So now what happened, response was step 1, Roger start with 5. 2 cans cross 3 ball is equal to 6 new ball. So total 5 plus 6 is equal to 11. You can even today you can put this command to ChatGPT, and if you see ChatGPT reply like this, like let's think by step, and it will give you all the step, right? So this simple techniques, it's called chain of thoughts, where you basically break down the problems into smaller sub problems, and then you think about it. And this is so powerful. They really tried it in the school problem, and they find out that accuracy jumped from 17.7 to 56.9. Yeah, and this is the real example from this research paper which I have quoted there. This is also into the link. You can go and read. This was really good first time introduced concept in 2022, right? So let's understand why does it even work, right? So I will give you few analogy, like we'll try to understand from engineering point of view, like why this even really work, right? So first is more token is equal to more compute. So when you give models like step by step and instructions, which means like model has more tokens, and which means it will do more processing, right? So simply by like breaking it into step 1, step 2, it will do more processing. And if it will do more processing, the chances that it will make things better or right will increase more, right? So next thing is committed to intermediate step. So which means like when it actually work on one step, so it's not directly jump to the conclusion. It's like do one step, lock it, and then move to another step. Our teachers, math teacher, used to give us marks on step marking also. Like it's not about just jumping to the answers, it's about how we are solving the problem. So it is the same thing. When you break into the smaller problems, it's easier to catch any error. So for example, if any steps you are doing wrong, it's easier to catch than directly jumping to the solution, right? So you can ask me that this is very simple things, just adding one line that let's think step by step. Why we need to even do that? Why not the model do it by itself, right? So good news is AI company also read this research paper, and now the model does it on its own. So but the thing is, they just rename the model and called is the reasoning model. So now if you see all the advanced model like Anthropic Opus Cloud so 4.7 or DeepSeek R1 or latest Chat GPT, what they do is they have these things inbuilt. So whenever you talk to them, they basically like you see like they prompt like thinking, or Claude say like extended thinking. They basically break it into the multiple step inside the model itself, and then they basically give you the response. It's just like they rename it and call it reasoning model. So reasoning model is just like you say advancement over the normal model, where model do this thinking, basically breaking is like your statement into multiple step inside itself, right? You can say like okay now model is doing itself, right? then why we are still learning it? But it is costly. So if you use the reasoning model, it is costly, right? So let's see. Now there are two ways of doing the same thinking, but at very different cost, right? So first thing is prompted chain of thought, which is like classical. Before we used to say that. So here, as an engineer or who is like doing the prompting to the model, we basically break it down. We say like simple step, let's think step by step. That's like a very generic statement, but usually when we give the prompt, we provided that into the step by step things. So right, so this is like a classical thinking where as an engineer, as a users, we break it there. Second thing is reasoning model, where this chain of thought is built in inside the models, and it basically before doing the response, it break the problems and then think step by step, right? And it is really better on like solving problems than traditional models and doing like complex calculation. When OpenAI launched their O3 model, they did the experiment, they run it on Codeforce, and they also use like a math Olympiad, and they really find out that their model is performing well. On Codeforce, the model was performing equivalent to top 200 human in the world, right? So the real question is, when is it worth it? So since we have an advanced model, does it mean we should always use it? Because it is obviously costing you the money, right? So we have like normal model, or we have like chain of thought using prompts, or the reasoning model. So we should, as an engineer, we should decide when to use it, because we are paying money for it, right? So let's discuss about it. When you have something which required thinking, or which required some step-by-step things, for example, you are solving a math using model, or you are doing some plannings, like where you need to break down into multiple steps, or you are doing debugging or some complex instructions, right? Anywhere where you need to break things into the step, you will use COT. When I say COT, which means like either you can use this chain of thought using a prompt, or you can use the reasoning model, depend upon your situation, because both has a different cost, right? When you do not need to use it, right? So thing is, when you are doing some factual thing, for example, you are just doing like what is the capital of France, or when you are actually just doing some labeling, or you say like summarize my doc, or just like one star transformations, when you do something like a simple where step is defined but you have to just go execute it, or when you're doing a tool calling, right? So for example, when you're calling an MCP server, reading your tickets internal, for example, or you're or you have your code and you are just writing it, then you don't need to use this reasoning model, right? So let's talk about it, because thinking costs real money, right? So if you see, if you are doing like a direct answer, this is just like a relative figure. If you are directly asking model to give you answer, a simple model, for example, it is burning like 50 tokens, right? And then if you add prompt to it, like think step by step or break it, so it will usually like take 6 times more tokens, which is like a 300 approximately. But at the same time, if you use like a reasoning model, it take around 60 times more token, because it's reasoning internally. It's not visible to use. Some model even say that what it is doing, or simply say thinking, but it's break into the problem inside, and then actually do a lot of processing, which takes real money, right? So if you see here, the difference is 60 times. So either like $1 versus $60. So we have to be really frugal in deciding which model to use on what situations. Here is the fun part. In agentic system, there is no one answer, because if you see, agentic system are complex and there are multiple steps involved, right? So to optimize it, we will use the model which needed for which step. So in this course, we will build AI digest. So it will basically crawl the web, take all news from web, and then rank it based on top news, and then give you the summary, like what is the top 5 news or 10 news for the day. So let's think from that perspective. So for example, there will be something called planner. So if I'm designing this system, we need some agent which will basically plan all those things. So there, yes, I need to use the reasoning model, because then I need to think about the step. And next is like tool calling. For example, I need to crawl the web, right? I don't need a reasoning model. I can simply use the normal model, which can crawl the webs and give me the data. And again, I need to review it. I need to rank it, like which news is important. So for that, I will use the reasoning model. And next, like when I know like which news is important, I need to summarize it. For that, I don't need a advanced model. A normal model will summarize it better. So see how we are optimizing the cost. So based on our step, we are basically optimizing the cost. And this is real. For example, we have used either Claude or Codex or the Klein Ru code or Kiro, anything. So if you see, there are section to choose the model where they have multiple model, and they also have like something called auto, and you say auto is recommended. Why? Because based on the step you are doing, for example, sometime you are in planning state where you are just planning what to build. In that case, they will use the advanced reasoning model. And the next thing is like execution, or you ask like your AI to just read this ticket and solve it. So for example, for reading, it doesn't need advanced model, so it can use the normal model for reading. So based on your use case, see, it is using different model and optimizing the cost. So that's why it is very important to understand the fundamental concept, what chain of thought is, what reasoning model is, so that even we have advanced model, it doesn't mean that we have to always use the bigger gun, right? So we will decide which is the right step for us, right? So the next question is, thinking isn't knowing, right? So for example, model does not have context around your own information. For example, it doesn't know your tickets, or it doesn't know your product. So no matter how much effort you put in chain of thoughts, reasoning model, it will be useless for your custom use case, right? Anything you have your information behind your SSO, model can't access it, right? So we will discuss in the next episode how we'll give the information to the model not train on, right? See you there. Hi, if you watched till here, thank you. Please do like, share and subscribe. It will help and motivate me to make this course further. See you into the next episode. Till then, bye bye.